problem with their feet or something. And so what are you trying to do? You're trying to extend the life. The whole purpose of retrofitting is to extend the life.
Yes.
Nobody wants to kill grandma or grandpa, okay? We want them to live. So whenever I see an old building, I always refer to them either as a grandma or a grandpa. And sometimes you have two choices. Sometimes, you could be at the end where maybe there's nothing you can really do and it's over. Okay, there's a lifespan. Everything has a lifespan. We all have a lifespan. You have a clock and I have a clock. Nothing is infinite.
Yes.
So let's not kid ourselves and think that we can, make any building last forever. All right. There was one thing that I learned, and one of my professors taught me a very famous expression that I have never forgotten. He taught me. He said, "Nothing lasts forever." So, and we can go back in history and look at, the Romans, the Greeks. They did magnificent work, but at a certain point, things are going to fall apart. So the whole idea behind retrofitting is we are thinking of ways how we can extend the life of the building.
Yes.
And so it is a very specialized area because it's not designing a new building. That's the key difference. When you design a new building, you start from zero and you prepare drawings and you start from nothing and you create a new structure. In retrofitting, you are working with the history of that building. You're working with the designer and the maintenance of that building that has been there for 50, 60, maybe 100 years before you. So you are dealing with existing situations that you have no control over. And so there are four materials that we use in civil engineering worldwide. In India, it's primarily two, but the four materials are steel, concrete, masonry, and wood.
Yes.
Wood is predominantly used in the United States. 80% of our floor space is made out of wood buildings. Okay, which I'm not a big fan of, but that's the way it is. In India, as I know it, there's very small percentage, probably zero, of wood frame type of structures. It's mostly reinforced concrete or steel. Steel being the more newer type high-rise buildings, but most of the residential and commercial buildings are reinforced concrete. So the lifespan of reinforced concrete is much longer in general, but given what happened in Florida, now reinforced concrete buildings are now coming under more scrutiny because of the collapse. But to get back to your question, so the whole idea of retrofit is we are trying to extend the life. We're looking for ways, cost-effective ways, that we can keep the building in reasonable condition for occupancy, safe occupancy, and see how many more years we can get out of it. That's really the whole idea.
Yes. Yes. The next general question, this was a repeated question which was coming up. Let's say there is a retrofitting assignment and the foundation is inadequate because it was designed for certain loads, and now there is a higher amount of load which are likely to be applied on the structure. Then how to retrofit the foundation?
Yes, we do this a lot. Uh, I do a lot of work in renewable energy. I design wind towers,
Okay.
which are the windmills.
Mm.
And this is a very common question in windmills because what they're doing now is I started in the wind energy industry almost 22 years ago and have designed a lot of wind towers and foundations. And what's happening now is those windmills, which were designed for 20-year service life, are now being recommissioned for an additional 20 years. So what they're doing is they're taking the towers off and putting bigger towers with heavier wind turbines.
Right.
When I started in the wind business, we were doing 40-meter tall, 60-meter tall towers. Now we're doing 100-meter tall towers, and the weight is much higher. So what we do is we look at the foundation, we go back to the original design, and there are ways that we can retrofit it. We can attach, a what we call a pertinent structure, attach it to the existing foundation, make it larger. We can put piles in the ground. We can expand on that existing foundation if possible to sustain the higher loads. We can do it with buildings also. We do it all the time with residential structures, smaller structures. When you get into high rises, that gets a little bit more difficult because that's more expensive. But usually the valuation is there to warrant the cost. You know, uh, I'll just give you a simple little. I'll give you one of the most major famous examples that's going on right now in San Francisco,
Yes.
which you may or may not heard of. I don't know if you've heard of the Millennial Tower.
Yes.
So Millennial Tower is a new building built within the last, I don't know, 7 or 8 years. It is $600 million, over a half a billion US dollars, right, to build this tower. I forgot how many stories it is, somewhere 100 stories or something like that. And the building is sinking, okay? And it's sinking to the point where it's starting to tilt. So you can imagine, you know, that you would think that on a major tower like this, that's not supposed to happen, but it does. And what they have found was that the foundation for that tower does not go down to bedrock. It's built on piles, and they stopped short of the bedrock. Now, why they did that, I have no idea, but that's a major, major mistake. So now they're talking about retrofitting that high-rise building, which is going to cost, I'm sure, $50–100 million probably. It's a major expense, but you know, what are you going to do? It's a 600 million. See, this is the thing about civil engineering. We work on very big stuff, and mistakes are very expensive. So you really, you know, I could list you, could do a whole show just on mistakes, okay? Major mistakes. Millennial Tower is a good example. The other one that I always use is the building of the Hong Kong airport, which has been sinking for 30 years. Now, how can you build an airport on an artificial island and then it sinks? You know, these are the kind of things that we're supposed to prevent from happening, but they do happen.
Mm.
And the cost of fixing them, very expensive, but there is always a solution, usually.
Yes.
Usually there is always a solution. Now, sometimes, and this is where judgment comes in, sometimes you get to the point where the cost of the fix, the cost of the repair is more than replacing the building or more than replacing the structure. And that's where you have to make a economics decision, a business decision to advise your client that, you know, it's not worth it. It's just not, it's not viable. And that does happen. That does happen. And that's when, you know, it's the same thing that doctors do when they have a patient that is terminally ill. In America, we call it hospice. We have to make a decision whether we're going to send the patient to hospice, which means there's nothing more we can do for them.
Yes.
And it's a painful decision and nobody likes to go there. But sometimes you don't have a choice because you can't have a building. Buildings, you know, are central components of our society. Thousands, millions of people are, where do they live? They live in buildings. Where do they work? They work in buildings. And so it's a central part of our infrastructure. When you know, in India, when you leave your home, you're probably in a high rise or a flat or something like that. And then you drive or you take a bus or train. And then where do you go? You go to another office, which is also a building. So you are spending 90% of your life somewhere in a building somewhere, unless you're, you know, working outside. So it's a central part of our lifestyle, and it needs to be paid attention to.
Yes.
You know.
Yes. The next question, which I could see, which was again repeating in nature, that while approaching retrofitting, what kind of NDT test will be required?
So, okay, so for reinforced concrete and steel, I'll talk about those two because those are predominantly what's used in Indian buildings, you know, if they're steel. So first thing is when we do the examination, we want to do our examination at the least cost. And least cost means visual or using certain instruments. And the instrumentation that we use, so we have, first of all, X-ray, which is pretty powerful for looking at steel, but it cannot tell you the condition of the steel. It will tell you whether the steel is there or not. We have ultrasound, again, same kind of device, but these have limitations in terms of how far deep you can look. So what I usually look for when I'm looking at a building, I want to first say, like what happened in Florida. Everyone in the press is saying, "Oh, this was a sudden collapse. Oh, it happened all of a sudden." And this is not true. There is no such thing as a sudden collapse. I want to make that point clear. Every building, bridge, before it collapsed, is going to give you signals. Now, it may not be signals to the layman, but definitely signals for a structural engineer. It will tell you that, hey, I'm about to fail, you better run away. It will give you signals. So one of those signals that I look for is deflection. Concrete buildings are designed to deflect. They're designed to show cracking on purpose. It's written into our codes. So if a concrete building or a bridge is experiencing issues, you're first going to see cracking, a lot of cracking, and you're going to see cracking in certain locations, certain critical locations, components. For example, in a building, it will be where the beams and the columns meet, or it'll be where the center span is. So the best tool are your eyes, of course, and your brain. So you look and you see the cracks and you evaluate it. You don't need any special instrumentation. That's the number one most powerful tool to see what's happening with it, is to just look at it. I mean, look at it with photographs, sometimes with high-powered photography, okay, and examine it from get an experienced person who's been doing this, because every crack has a different meaning. Cracks are not equal. So from there, you can deduce whether or not the building is experiencing stress. So the NDT, non-destructive testing tools, there are a lot of instruments and everything, but I say the most powerful non-destructive testing tool are your eyes, just to look at the building. The other non-destructive testing tool that is very powerful, which your eyes cannot necessarily see, is deflection, which is to use instruments from surveyors like lasers and measurement devices to see if the building is shifting. Is the column doing this? Is the column doing this? Those kind of tools, which are really not difficult to do, will tell you whether or not the structure is moving. It doesn't have to be the Leaning Tower of Pisa. It can be moving only by a few inches, and that's enough of a signal to tell you that something is happening.
Yes, great.
Yes.
See, another repeated question which was coming, like how to estimate the life of the retrofitted structure, or let's say where there is a older structure, then what could be the residual life? Is there any means
Oh,
by?
so, okay, so this question, I get asked this question all the time because clients want to know if I'm asking them to spend $100,000, $500,000, $1 million, what are they going to get out of it?
Yes.
So there are two answers to this question. The first answer, which is the official answer, and then I'll give you the unofficial answer.
Okay.
The official answer, which is what you put in writing, which in America, we have to be very careful what we say in writing. And I'll help you answer it. It's like me saying to you, Mr. Shah, how long do you think you can live? Okay. Now you may say, I want to live to be 100. Great. But you could walk outside tomorrow, get hit by a scooter, and that's over. Okay. So, or I could walk outside, get hit by a bus, right? And it's over.
Yes.
Even though I say I want to live to be 100. So you can see that we cannot predict our own life, right? How do you expect us to predict the life of a building? It's exactly the same thing, right? So the official answer is we don't know.
Yes.
I cannot and never will. My insurance company would hang me if I ever put in any report saying, oh, the building's going to last for so many years. Now, that's the official answer for legal purposes. That's the answer that I use in writing. The unofficial answer, okay, so I'll give you some of the best examples in the world, right? One of my most favorite monuments in the world, the Taj Mahal. 500 years, right? And right now it's under threat from the Jamna River,
Yeah.
but 500 years, that's pretty good, you know? I hope that I can design something that's going to last for 500 years, okay? So you have Taj Mahal, you have Red Fort, right? I've been to New Delhi, Red Fort. You have so many beautiful monuments in India. Oh my goodness. 100 years for these monuments is nothing, right? I don't think that is anything in America that we're building or have built. I doubt the Golden Gate Bridge is going to surpass 100 years. We're approaching 90 years now.
Mm.
I think the Golden Gate Bridge, being the beautiful bridge that it is, but it's made out of steel, I doubt. At 100 years, I think we're going to start having, we're already having rust issues with that. So when it comes to longevity, I think the ancient our predecessors who were building stuff for monuments that were going to last forever, and there's so many examples. I mean, we don't have to just look at the pyramids, but I'm a big fan. When I come to India, I visited Ajanta and Ellora caves. These are carved out of rock, okay? These are what, 1,000 years old, 2,000 years old, you know, and they're still there. Now, you know, they need a little maintenance, but they're still standing. So the answer to your question is I rank them based upon materials. Number one is masonry and concrete has definitely the proven the test of time, starting before the Romans, before the Greeks, starting with the Egyptians. Steel is a new material, is roughly 150 years old. You know, in the mid 19th century, we're now a little bit over 150 years, maybe 170 years, where we're using iron and steel. But we know that iron and steel has finite life because of rust. So I would venture to say, you know, any high-rise building, I doubt you're going to get more than 100 years of really effective service life out of a high-rise building. Wood is the worst because wood gets eaten by termites. And we have so many buildings in Los Angeles that are over 50 years old now, right? I'm over 50 years old. So we have buildings which were built from wood that were built in the 1940s, built in the 1920s. And the interesting thing is that the valuation of these wood buildings, because of their location, hasn't gone down, it's gone up. You know, which is to me boggles my imagination. But anyway, that people would pay that kind of money for a wood building. We have buildings in LA built in the 1920s were probably built for $10,000 or $8,000 and are selling for $3 million today. You know, obviously because they're paying for location. So the simple answer is, well, the official answer is we don't know. The unofficial answer is that concrete and steel, obviously at the top, masonry definitely at the top of the list, and then the rest of them are less. But for everything that's being built, like I've looked at the skyline in Bombay recently, all these high-rise buildings built out of steel, I don't think you get more than 100 years out of them because we don't have any evidence. We have no track record to show that high-rise buildings can last more than 100 years.
Yes. So
Yeah.
the next question was in the similar line, which was repeating in the questions. Like durability is the major concern for the reinforced concrete structure. So what will be our approach for the corroded structure? Let's say the corrosion has begun.
Yes. So steel is a beautiful material, and steel is what has created the modern day skyline, right? Because concrete, we really have a tough time building with concrete. Once we pass 30 stories, the problem with concrete is pumping and getting it up that high. Plus, concrete is just way too heavy. It's a really heavy material. So all your major high rises are steel. It's fast, economical, and you can build to the sky. I mean, Dubai, you have the uh, Burj Khalifa. And now Burj Khalifa is 2,500 feet, right?
Mm.
Half a mile. Can you imagine? And then they have another tower that's under construction in on the other side of Saudi Arabia in Jeddah. They're trying to hit 3,500 feet. You know, this is all ego trip, by the way. This is just the Arabs trying to outdo each other. So the problem with steel is that it corrodes, as you said, and the corrosion comes from high humidity.
Yes.
This is a very, very big problem in coastal communities, Bombay being number one. I've been to Bombay many times. Right now, you have the monsoon season there right now. Everything is wet. It's raining every day, right? So the steel corrodes. So I am a very big fan of using corrosion resistant steel. I have a project right now. I can't tell you who the customer is, but it's a huge project. Okay. I'll just tell you it is a major stadium in the Southern California area. Okay. We're talking about a baseball stadium. I can't tell you where it is or who the client is. And they have these ramps that go into the stadium, carries thousands of people. They have shut these ramps down because of the corrosion. They're afraid they won't drive on them because they're afraid that the ramp is going to collapse. And this stadium is probably, it's probably 50 years old, I'm guessing, but because of the corrosion. So the first answer is anytime you're in a corrosive environment, you should not be using conventional steel. You should be using either a corrosion protected steel, which we have in the United States, the standard is called Core 10. That's in the American Institute of Steel Construction. It's a specially fabricated steel. Or you should be going with stainless steel. And stainless steel is available. Now they have also epoxy coated rebar where you take the rebar and you coat it with an epoxy. I haven't had good, I have not seen good performance from that product personally, so I don't specify it. They also have what they call powder coated rebar. These are the products that are available. I don't use the powder coated or the epoxy coated. I don't have that much faith in them. But the corrosion resistant steel and the stainless steel is the way to go. Now, to get to your main point of your question, if you have found corrosion in the structure, what do you do? So that is a very difficult situation because rebar, which is in the concrete, and if it's corroding, then the concrete is actually falling off the structure and you can see the corrosion. You can't pull the rebar out. You
Yeah.
would have to tear the structure down. So you have to either retrofit it. You can use carbon fiber. We use fiber composite layers. We can attach it to the concrete structure. We've done this with columns. We've done it with certain bridge sections. And you have to do an evaluation. And this is a huge topic for United States, and I would say also probably for countries like India, because a lot of the bridges in United States were built. Many of them are approaching 100 years, and we've had a couple bridges just collapse. We've had a few of them. So these are warning signs, because it doesn't take the whole bridge to collapse. It only takes one bolt or one critical section and the bridge collapses. Everything is dependent on a few connections.
Yes.
So we have to do a thorough examination, and all of this costs money. So clients, being public clients, government clients, or private clients, they have to first of all understand that your structure, your infrastructure, your bridge, your building, it has a lifespan to it, and you have to invest in it. You have to do maintenance. You have to inspect it. You can't just expect that it's just going to stay there forever. And that mentality needs to be educated into our customer base.
Yes.
Yeah.
And there are a few students who joined the meeting, and they mentioned this similar kind of a question, that what do you think, that what is the market for a retrofitting? Yeah.
Market meaning, oh, you mean for work?
In terms of a career, let's say they want to pursue career in a retrofitting.
Oh, I see. Careers. Okay. Well, okay. So that's a great question. So the first thing is, if you look at the curriculum in the universities, and I'm not just talking about America, I'll talk about United States, but I think also it's true in India.
Mm.
How many classes, how many professors have ever been trained in retrofitting? I think the number is somewhere between 0 and 0. Okay.
Yes.
So, and it's not their fault.
Mm.
You know, so first of all, let me first back up that answer before I just make a conclusion. Let me first give you the reasoning,
Mm.
because I was a faculty member. How do professors become professors? Well, a professor becomes a professor. First, he goes to school. He's a very good student. He gets a bachelor's degree. Then his professor says, oh, you should do a master's degree. So then he does a master's degree, right? Oh, you're very smart. You're very smart. Well, why don't you do a PhD? So then he goes on, he does a PhD. And then when he finishes PhD, what does he do? He goes and joins the university. Very rarely, I mean, of course, there are some PhDs who go out and actually will join a company. But in their career line, if you look at their career path, most of them, and especially the more prestigious the university, the more this is true. They're mostly academically trained. That's not a bad thing, but they haven't seen anything practical. They haven't actually worked on a real project. So the knowledge base for retrofitting is 100% from practical people, practicing engineers, people who are in the field, because that's the only way you can learn it. Now, if you look at the entire marketplace, so let's talk about career-wise, okay? I also worked for large firms. Before I had my own company, I worked for a large company, and also I worked for NASA. I was also in the aerospace industry for 5 years. I worked on planes, and I worked on spacecraft. So big companies, and I know, we'll take a few examples. I mean, in the U.S., we have, big companies like Fluor, Parsons, Bechtel. In India, you have Larsen and Toubro, if I'm saying it correctly, right? What kind of projects do? They do, power plants, major bridges, all new stuff, and they do stuff which has high dollar volume,
Yes.
because big companies can do projects which have high dollar volume. So retrofitting is a highly specialized niche market, which most big companies, they don't want to mess around with it. And I'll tell you why. It's a business decision. It's not that they don't want to do it. Well, they don't want to do it, but the reason they don't want to do it, because the revenue is very much less. If Larsen and Toubro is going to compete on a project to do power plant for the city of Mumbai or for New Delhi, that's $1 billion plus project. Why would they want to go mess around with some, rinky-dink little retrofit job, which may be $1 million, and it'll be $1 million would be a big budget. It'll be $1 million to retrofit a building, and then you're going to have owners who are going to sit there and say, well, we don't want to spend $1 million. We want to spend $800,000. They wasted their time, right? So most graduates, when they graduate, they will go and work for these big firms, and they'll miss this whole opportunity. Now, why do I like it? I'll tell you why I like it. Because it's a market where a small business, because I'm a small business, we thrive in this market. Because I cannot handle $1 billion project in my company. It's too big. So let Larsen and Toubro and Parsons and Bechtel, they can have those jobs, because those are large government clients. You need, 100 people just in your accounting department, right, to manage the invoicing. But for retrofit, I'm working with private clients. There's thousands of buildings that need my services. And it's specialized. Even I have been hired by these big firms to consult with them, because they don't know what to do. It's not an expertise that they have. So for me, it's a very nice niche market, and I can stay where I am, and I'm in demand because there's so many old buildings. So it's a great career choice. But if you're interested in going in that direction, then you need to go and work for somebody like me or some smaller firm. The salary won't be as high. You're not going to get the higher salary like Larsen and Toubro. They're not going to give you a car and you're flat and then pay all your expenses. Okay, you have to start from the bottom and work your way up. And so I'm not trying to be generational here, but a lot of the younger generation, first of all, civil engineering is a long-term career. It takes 7 to 10 years to really even call yourself an engineer. People graduate with master's degrees and they think, oh, I'm an engineer. No, you're not an engineer, okay? You just got out of the school, all right? You only got roughly 5% of the knowledge to call yourself an engineer. There's 95% more you need to learn. And I know the young people, they don't like to hear this. but that's the truth. In software, which is the hot topic today, you can come out, write an app, you can write an app on how to, order pizza or whatever, and maybe it makes $1 billion. I don't know. That's not my field, but it's a long-term career. It's not a short-term career. You have to be looking at it. I've been in the business for 39 years. I'm still learning new things every day. I still have stuff that I find it very interesting. I still have buildings that I look at that I've never seen this happen before. So for me, it's very interesting. It's very innovative, and it never stops. It's very creative. You're always learning. Even I'm learning. I see stuff that I haven't seen before, like this Florida collapse. I'm learning so much on this. This is a new topic now. So career-wise, the other positive thing is, see, if you work, and again, I'm speaking to the students, the younger folks, in retrofit, you really have the whole world is open to you. See, if you work on power plants or nuclear power plants, there's a lot of work there, certainly, but you're in a very select market. And so career-wise, you have to work for one of the big firms. You cannot go work for a small firm. There's no small firm that's designing nuclear power plants, although we have done work like that for larger firms. But retrofit is a highly specialized niche, and so I would advise that if you're interested in that, you have to find a firm that specializes in that and then work for them, because that's where you're going to learn.
Yes. Yes, indeed, there is a great ample opportunities available in this market, right? Okay, so
Yes. Well, because India has first of all, the population, right?
yes.
1.3 billion people. Okay.
Mm,
That's a lot of people. That's 4 times the size of the United States.
mm,
Okay. And India has become more of an urban it's an urbanizing population.
mm,
And you have many, many buildings. You have buildings in India that were built by the British 200 years ago. They're still in operation.
mm.
These buildings need attention.
Yes.
Yeah. And they need a lot of attention, and they need money.
Mm,
And they need engineers to show them how they can maybe keep them going, or maybe they need to be retrofitted or torn down,
mm.
So there's a lot of work in India. In this field, there's a lot of work.
Yes. Yeah.
Yeah.
Couple of interesting questions were what is the status in America with respect to this retrofitting? Let's say in India, as I said, it is not properly organized, and also there are many structures where highly this kind of services required. So, is it a similar kind of state in America also?
So first of all, let's look at America. Remember, America is 50 states,
Mm,
right? And we really are 50 separate countries because each state, I think India, so forgive me, I could be wrong here, but I think India has 22 provinces, if I'm not mistaken. So I have traveled extensively in India. The difference between Maharashtra and Madhya Pradesh
mm,
is huge, okay?
mm,
Orissa to Kerala. Yeah, it's all part of India, but you know that the language is different, the rules are different, the culture is even different as you travel across the country. Well, the same thing is true in the US.
mm,
So you have 50 states. The most proactive state when it comes to retrofitting and repair is California. So California is number one. California is the largest state. Total population, well, legal population is 40 million, illegal 50 million, but yeah, that's the unofficial population, but it's somewhere between 40 and 50 million. State of California is the 5th largest economy in the world. It has a larger economy than the entire country of India, okay? Which is unbelievable to me that 40 million people produce a GDP of close to $3 trillion a year and is larger than the entire economy GDP of India, okay? So it's a highly concentrated population, and we have many, many buildings. They're not as old as Indian buildings, but we have so many buildings that need attention, and there are lots of regulations that have been passed. So California is very vigilant, and the other states usually follow. And because California is in a seismic zone, it has a lot of earthquake risk. So there's constantly retrofitting going on all the time. In California, Oregon, and Washington, a lot of work. Now, the other area which has a lot of work, which is in bridges and also in buildings, but not as much regulated as California and the West Coast, is Massachusetts, New York, the East Coast, because they have a lot of older bridges. They have a lot of older buildings, but they don't have the earthquake risk. So the West Coast, I think, is where most of the rules are coming out of. And we have a series of codes that address the whole concept of retrofitting and looking at the service life of a building. We have some pretty good building codes, but a lot of this is learned in the field. Like what I'm telling you about is, I mean, the information that I'm sharing with you is not, there's a few textbooks that discuss it, but see, most of the people that are doing this, such as myself, I've written 2 textbooks. I wrote 2 textbooks about 20 years ago. I don't have time to write a textbook right now because I'm too busy doing what I'm doing. And the professors who write the textbooks, they don't know anything about what we do. So there's very limited amount of information. There are some good papers, like once in a while I'll go publish a paper. And that's why I've started publishing on YouTube, to try to share the information. So the access to the information is very limited. It's a very small circle. When you look at the entire profession of structural engineering and civil engineering, we're a very small niche within that big circle, and almost non-existent in the academic circles, which we need to have more research done. We need to have more testing done in this area. Now, California has done a lot of testing on retrofitting and has been very proactive. So the answer to your question is, it would be West Coast. You know, not that we need any more people in California, but you're welcome. You can come. But yeah, there's definitely a demand for services in that area. Right now in Florida, because of what happened in Florida, there's a shortage of structural engineers to look at their buildings. They can't find them because everybody now has gone crazy with what happened. So now everybody wants their buildings looked at, like right now, all of a sudden. So when these things happen, even we have gotten quite a bit of demand for services. So, you know, unfortunately, due to the collapse, but the path and the location is to look for firms that specialize in this, and then you will learn what you need to learn in those firms.
Yes. Yes, there was one interesting question, that what are the legal implications whenever we are approaching this retrofitting assignments? So have you come across any such kind of a situation?
Well, so in the United States, this is a huge issue because we are a very legally minded country, right? There's a law for everything. So you have to be very careful as a structural engineer on your contract and what you can promise. As I told you, in my performance of services, I never will tell a client that their building is going to last for so many years. It's like me telling you, oh yeah, Bubban, you're going to live to be 100. Don't worry about it. You're good, right? I mean, how can I make a statement like that? I'm sure you're in beautiful health and everything, but circumstances will come up. You know, we don't know what's going to happen in the future. So whenever I do a retrofit, I have certain clauses that I put in my agreements, which are limitations of liabilities. By law, under California law, and most of the other states probably are similar, by law, my liability extends to a maximum of 10 years, which is not really a lot of time. But there's 2 rules on the books. There's the 4-year rule and the 10-year rule. The 4-year rule is what they call a defect that is visible. In other words, the building is built, and all of a sudden in the first 6 months, the building is doing this, right? You can see it, it's cracking. You have 4 years to file a claim on that. That's a visible defect, what they call a patent defect. Then they have the 10-year rule, which is the hidden defect, which is a latent defect. And that is, okay, you built the building, and in the 9th year, all of a sudden the building is doing this. It's starting to tilt, but we didn't know that because there were cracks in the foundation, and now we observed those cracks. We discovered them in the 9th year. In the 11th month, you can file a claim against the design professional. Well, once you pass the 10-year statute of limitations, so now you're at the 10th year and 1 month, then the original designers and the builder is out, they're out of, technically out of the claim.
Okay.
Yeah. So, and we have a lot of buildings, I'm telling you, we got a lot of buildings that were built wrong that are 20, 30 years old, but they have no recourse against the original builder because they're out of the 10-year statute of limitations. I can't speak for Indian law, but that's what it is in California.
Yes. Yes. Okay. So the next question, which was there, like, is there any age criteria is decided like this beyond this age structure cannot be retrofitted? Let's say 30 years, 40 years.
So, okay, there is no such criteria, and I'll tell you why. We have all kinds of really what I call very innovative tools to retrofit almost anything, provided it's not about to collapse. And I have worked with there are companies in Europe, more so in Europe, that have retrofitted what they call ancient or historic structures, uh, monuments that were built 1,000 years ago. So, but they're not occupying people. We just want to make sure that they don't fall down. So when you ask the question retrofit, are we retrofitting for the purpose of just keeping it alive so that you can look at it like it's a Greek structure or whatever, and you just want to make sure that the columns don't collapse? We want to retrofit it just so that it remains in place, or are we retrofitting it for it to be occupied? And then it depends, what are we retrofitting? Is it a building where, if it's a hospital structure, the lifespan on a hospital structure is generally longer than most buildings because they're better designed. But if we have to retrofit a hospital structure, the criteria is much higher than, say, unfortunately, for retrofitting like a residential apartment structure. This is just the way the priorities are. But I'll give you an interesting little fact, which I share with my audiences in the United States. I always ask them this question: of all the buildings that are built in the US, which type of building is the safest building and has the highest life expectancy, right? So before I give you the answer, would you care to guess? Try to guess, and then I'll tell you what the answer is. But do you have any idea? I'm asking you.
Yeah, no.
No, okay. So the best, safest structure, without a doubt, best for hurricane, earthquake, blast, terrorist attack, you name it. The best structure that's the best designed for long term are prisons. And think about it, because they're all heavily reinforced concrete, 12-inch thick walls. Now, I'm not saying that we want to live there, but I'm just letting you know, if we ever have a nuclear attack, you and I may not be here, but the inmates will be here. Okay. Now, I don't know about Indian prisons. I'm talking about in the United States. Our prison structures are heavily fortified. Heavily fortified. They are blast resistant. They are bomb resistant. They are fire resistant. They are hurricane resistant. And they're not high-rise buildings. They're mostly flat structures, maximum 2 or 3 stories. So they have one of the most sustainable and solid kinds of buildings are prisons. So they are actually the safest structures that we have. Interesting little note I just thought I would add to the discussion.
Yes. Yeah, one more chat was popping up. Someone is asking that what is the most challenging work you have done up till now related to retrofitting? If you can share some insight from the same.
So I've done churches that are 100 years old. Done a few of those. Those are very challenging because a 100-year-old building, we just, we had one case where we had a building that was 100 years old, but it burned. So we had to replace it. But churches, I think, are very, very challenging buildings because churches, and we're talking about Christian churches where they have very high vaulted, if you've ever been to a church in Europe, you see these very high ceilings, no columns. These are really, really complex structures built by engineers in the, well, go depending on how far you want to go back. Some of them are 1,000 years old. You know, Notre Dame in Paris. But in America, we have churches that are easily 100 years old. Those are very complex structures. And then the other one would be retrofitting for wind towers, because wind towers, again, reaching their service life of 20 years, and then trying to salvage those towers or salvage their foundations to last another 20 years. Those are complex. Those are complex projects, because even though a wind tower doesn't, nobody lives in a wind tower, but it's a machine which is producing power, and it's quite a heavy structure, and it's very tall, because now people are wanting to use foundations that were used in 1980 or 1990. They want to put a 100-meter tower on top of it. So we do a lot of those. Those are called repower projects, and that's become very popular lately. So I would say wind towers, bridges. Bridges are very complex retrofit items, and bridges need, bridges are lifeline structures because they carry so much traffic and everything, and they're highly critical structures to the infrastructure of a community. So bridges are definitely very challenging. So those would be my top three. But you do something for a person who owns a home, for him, that's the most important structure. So they all need attention. They all need the same level of attention.
Yes. Another general question which was coming, that in a retrofitting assignment, it is seen that let's say the building is 30, 40 years old. Now there is no design calculations, no drawings are available. So do you also have a similar kind of a situation, and then how do you come forward into this kind of assignment?
So we get this a lot. We have many buildings that we look at where there are no drawings. There are no plans, which is unfortunate. And this is where one advice that I would give to any of the people in the audience that are owners, who represent owners or work for companies that own property, the drawings and the plans are sacred documents. They are as valuable as the Bible and the Bhagavad Gita. Okay, they need to be scanned, and they need to be saved.
Yes.
Every time I go to a client, the plans are sitting in some dirty dustbin in the garage somewhere with dust on all of them. You need to treat them. They're more valuable than the family album, okay? Because they are the holy grail for us to figure out what happened.
Yes.
So every owner should find the plans for their buildings, scan them, and save them, you know? So if we don't have plans, then we have to construct them. So then that adds more cost to our work, because now the first thing we have to do is we have to go out and measure the structure, and we have to reconstruct a set of drawings.
Yes.
In other words, we have to create a set of drawings, and obviously we're not going to get all the information. We're going to do the best we can, and then we'll have to do some non-destructive testing or some destructive testing in order to find steel. But yeah, we have to then create the plans, and then we have to estimate what we think was there. It's not the best way to go, but if you don't have plans, you don't have plans. You have to start from somewhere, but we have to create them. It's so much better if we have them.
Yes. Yes. Another question from the few students, that what are the futuristic techniques which you may foresee in a retrofitting? So what are the current techniques available, and then what could be the future techniques?
So currently, we're using the fiber composite is very, even though that's not technically new, it's been around for almost 40 years now. But fiber composite, fiber reinforcement, using composite materials in general to add strength is the current status of technology that we're seeing being used. And then good old fashioned steel plating, just taking plates of steel, wrapping columns, that's a bit of an older technology. Sometimes just adding concrete or putting a ring around a column or adding steel plating to beams. These are techniques that are used. Sometimes we use post tensioning. There are some buildings that we have where the floor system is sagging. We may put a post tensioning system underneath it to tension it back up. The new techniques that are coming out, there's a lot of interesting research that's out there. The problem in our profession is that in civil engineering, we are not as good as the software industry. Software industry, see, they don't have first of all, software, if you write a bad software app and your app doesn't work, nobody gets killed. The only thing that happens is you don't get your pizza on time, right? So it's not a big deal. It's not good, but no one's going to get hurt. Okay. So Uber can develop a software and hit the market and go crazy. In our industry, it takes time because anything we do in our industry, it needs to be tested. So if you come up with a new idea, it could take 5, 10, 15 years before that really hits the market.
Yes.
So we're very slow for good reason. If you come up with a new technique to retrofit a bridge, you're not going to get that to market in a week. Okay. It will take you years to be able to market that technology. So the new technologies that I see coming up are more advanced materials. We're seeing, use of higher strength concretes with mixing them with all kinds of innovative mixtures. There's a new, not new, but there's a material concrete that uses a sustainable concrete, which uses rubberized, it's called rubberized concrete, which uses the rubber fragments from spare tires or discarded tires. We have found that this added to concrete actually increases the ductility. It brings the strength down, but it increases the ductility. It's very good for the use in pavements. So this is wonderful because we have millions and millions, maybe billions of spare tires, and nobody knows what to do with them. They're putting them in landfills. If we could use them in our concrete, that's a terrific idea. That was pioneered in Arizona almost 25 years ago, 30 years ago. Still not as popular as I wish it would be, but that's a great material for pavements, which is also retrofitting and extending the life of roads. But for buildings, it hasn't been used. I've wanted to use it, rubberized concrete, even rubberized masonry, but it's not right now on the menu. But I think that would be a great material to develop. There's lots of ideas out there, and the whole technology of assessing structures. There's a European organization that I belong to, which is I would say they are actually more advanced than the US, to be honest with you, in terms of technology. The name of that organization, which is a French word that I can't remember, but the initials are FIB, Federation International Bureau or something like that, based out of Switzerland. And they have a beautiful concrete code. I'm a member of their organization because they have all kinds of tools and techniques, and they just had a symposium yesterday. They do something very interesting in Europe that I think that we should do actually in the US, but we don't do it. They will invite PhD thesis, PhD people who are completing their PhD thesis on some new technology. They'll invite them to the symposium to present their ideas to the practicing industry. So you have the academic, what I consider valuable research. There's a lot of useless research also. Okay, there's a lot of people just studying things that I think are completely dumb. Okay, although they don't want to admit it, but the useful research and then bringing it to the table to share with the practicing people. That's a really wonderful collaboration, and I think that model should be copied in other countries. Which in the United States, and I don't know, I can't say for India, but in the United States, the PhD guys are kind of off in a corner somewhere, publishing papers which only they read. So it's kind of they're in their own little bucket here, and the practicing professionals are over here, and they never actually meet each other. But in Europe, they actually have a forum, and it's a vetted forum. It's not that anybody can just go and present, but it's a very nice forum, and I'm a member of that organization, and I love the research that they produce and the documents that they have. It's based out of Switzerland's FIB, and they have a whole code which deals with concrete. They have a very, very nice set of documentation. I think very advanced.
Yeah, next question was like, what is your take on a long-term performance of structure which is retrofitted with carbon fiber?
So carbon fiber is very popular. Now, let me give you a little history on that. Carbon fiber was actually developed by the US military in the 60s. And the first application of carbon fiber was actually in military aircraft. And I actually was fortunate enough to have worked with carbon fiber right at the very, not the very onset, but because I worked on military jets when I was early on in my career in 1983 when I graduated. So I had a very nice exposure to it. So in aircraft, the new Boeing 777 is a carbon fiber plane. So, and it's a beautiful material. It's very lightweight and very high strength. Synthetic material. And it's replacing titanium and other materials that are used in jets. For structural applications, it has taken 40, 50, 60 years for it to progress, and now it is conventionally available. The only thing you have to be careful about using carbon fiber, the critical element is not the fiber. The material itself is very good. It's very strong. You can see most steels in the United States, most steels, the rebar is 60,000 PSI. I'm sorry, I don't have the metric equivalent for that. I think it's 22 megapascals or something like that. I'm sorry, I don't remember the metric version, but 60,000 PSI, or as we say, 60 KSI in English units. That's our standard rebar. In carbon fiber, the standard starts around 70 and can easily be 100 KSI. So it's a much stronger material. The problem, here's where the problem is. When you take concrete and you put carbon fiber on the concrete, your carbon fiber is stronger than the concrete. So what's going to fail is not the fiber, it's the bond. That's where we have an issue, and carbon fiber does not do well in fire. So if you have a fire, the carbon fiber is going to burn or it's going to peel. So whenever we use carbon fiber, which I have used on retrofitting buildings in Los Angeles, we have a big issue with the fire department because we have to either add sprinklers, we have to do something to deal with the fire potential. If you do have a fire, concrete is pretty good about withstanding fire. But thank you. Somebody in the chat section gave me the conversion, 415 megapascals, right, for 60 KSI steel. Thank you. So the problem is not with the fiber, it's with the bond. So some people have developed a way where they can take the fiber, and usually we use epoxy to bond it, but some people have come up with bolts that they can stick through the fiber to attach it, you know, to the concrete. But that's the biggest weakness of that material for retrofitting, and also its fire potential. Fire is a big problem.
Yes. Another question which was again repeating, like what should be done to prevent the failure which recently happened, let's say in the Florida. So what precaution or actions should be taken? And what do you think that all slab buildings should be immediately inspected? This is what the question.
Yeah, that's a great question. That's what we call in America. They call it the $64,000 question, but I'm going to raise the value. That's probably a $100 billion question. Okay, because so many buildings. There's millions of buildings. Latin America, Central America, India, Africa, Asia. The concrete buildings are all over the world. Okay. And this type of building, the flat slab building, is very common, very common. So the first thing is the building should be periodically inspected. And my number one criteria is deflection, is to survey the building to see, excuse me, to see, are the columns which were designed to be vertical, are they doing this? Are they doing this? Or are they doing that? Or are they doing that? And that's a simple check. And you would be surprised. I don't think any engineers are doing that, which is really surprising to me. Like when I looked at the reports on the Florida building from the engineer who did the examination, nobody's doing that survey. So I am actively advising and promoting that my colleagues in this business should be doing that. Now, one of the reasons is that, remember, most design firms are designing new structures. They're not expert in retrofitting or examining structures. So they don't think that way, you know. In my case, you have to be like a detective. It's a detective's job. Because what we have, so what do we have? What are we doing in retrofit? Well, what are we doing in failure analysis, like for Florida? So we are a detective, right? The body's dead. We have a dead body. Now we got to figure out what killed it. So we have to go backwards, as opposed to most designers who design new buildings. They're using the same techniques and everything over and over again. This is where I think the forensic experience is very valuable, because we get to see what didn't work. And then when I go design a new building, which we do, I apply many of those techniques to my new building, because I have already seen the quote dead building, the one that didn't work. So first thing is, we should be doing survey of these buildings for deflection. That should be done like right away. I've had at least a dozen clients contact me in Los Angeles, 22-story, 40-story, 10-story buildings. Everybody is nervous right now. And I told them, well, first thing we got to do is survey the building. We've got to first do an examination. It's just like, and I like to use medical examples. It's just like, you go, nobody expects that they're going to live their whole life without going to see the dentist, right? Is there anybody who expects that their teeth are going to last forever? You go see your dentist. I hope you see your dentist twice a year. You get it cleaned. You have them check the teeth, right? Same thing. But owners expect, oh, the building's going to last forever. No, it's not going to last forever. You got to go see your dentist. You've got to invest some money. And yes, sometimes there's going to be a cavity. So what do? If you have a cavity, you get it fixed, right? You don't just tell the dentist, well, I don't have money for you right now, so I'm just going to let that tooth go. I hope not. But you see, the idea of having it maintained is just like your body. You go for physical checkup, you go for a dental checkup. Well, this is the checkup on your building. And you shouldn't be waiting for someone else's building to collapse to go do it. It should be part of your routine.
Yes. So that chat is popping up. Like, do you think retrofitting is the delayed choice by the owners generally?
Owners don't want to do it. That's the flat answer. They don't want to do it. Remember, so owners are financial people. They look at the building as a profit center. And unfortunately, they look at us as a unnecessary cost, okay?
Yes.
Right? We are not the popular ones, okay? I always tell my clients, the person who does the tile work is more popular than me, okay? Because the owner spends money on the Italian tile, and the guy does the tile in the bathroom and in the kitchen, and everybody loves him, right? I show up and tell them the building is sinking and nobody wants to talk to me, okay? So I never get a Christmas card. Well, that's too bad, because your Italian tile is useless to you if the building is collapsing. So I'm sorry, our stuff is more important. But yeah, owners don't want to spend the money. I know that. And so they need to be educated. That's the thing. And most of them, you see, are financial people. They look at a building as, okay, I have a cost. I have so much rent. I have so much expense. I'm making so much money per month from rents. That's the way owners look at buildings. They look at it's a business. What they need to understand, yeah, it's a business. I agree with you. If you want your business to survive, then you've got to maintain what you have there, which requires investment, which means you need to spend money not just on your lawn and your air conditioning and these things that have immediate results. You need to look at the structure. And you can't just assume, like these people at the Millennial Tower who just assume, oh, well, it's a high-rise building, it's a $600 million project, was designed by a big company, so everything is okay. No. Some of the big firms, I hate to say it, I worked in a big firm. I won't mention any names. Some big firms, some of the engineers there are really bad. Okay. Some of them are just terrible. just because they work for a big firm doesn't guarantee that you're going to get quality out of them. It's the same thing with anything in life, right? There are some cars you buy where you spend a lot of money and you don't really get the best car. You know, I could give you some names, but I don't want to make people angry. But there are some cars, I've owned a lot of different cars. Just because you spend a lot of money does not guarantee that you're going to get the best product. You got to shop around and look at the, you know, the performance and the reputation. Same thing is true with engineers, and the same thing is true with buildings.
Yes. Next question was like, what are the softwares being used for this retrofitting kind of exercise?
So there's two classes of software for structural analysis. There's the conventional, what I call mainstream software, which is all the linear analysis software, which is the main market, and that's usually like SAP 2000. We use RISA, RISA, RISA 3D. Very good software program for practicing engineers. And there's a lot of them, okay? But those are the two that I remember of. There's at least a dozen. Now, I'm a person who's a creature of habit. I was trained on SAP 2000 when I was a student. I didn't like that software. It's kind of cumbersome. So I've been using RISA for 30 years. That's just my personal choice. I can use RISA in my sleep, and it takes care of probably 99% of the work or 98% of the work that we do. Then when you get into highly specialized structural analysis, where you are now going in a different domain, which is nonlinear analysis, what I call more PhD level type of analysis. So now you need a more sophisticated program. So there's Abacus, there is Adina out of MIT, ADINA. Abacus is very famous. A lot of people use Abacus in aerospace industry. And then there is non-SAP, which is also from Berkeley, from the same company, SAP 2000. These are nonlinear programs that are used to predict failure. Highly specialized software, normally used for more high-end work. And there's more out there, but those are the ones that I use. And interestingly enough, because at the stage of where I'm at in my career, I love to do the analysis. I still love to do engineering work, but I don't have the time to actually sit down and do the actual analysis. So I'll usually have one of my engineers train them, or I'll bring in a consultant to help me. But I know how to do the analysis. It's just that I don't have the time to actually sit in front of the computer and physically do it. But I know how to use the software. But those are some of the software packages that I use. And the interesting thing is that I think my personal favorite, which I used for my PhD program, is Adina, ADINA, which is out of MIT, or excuse me, out of Boston, because that software program has specific elements that you don't find in other software programs that can actually predict cracking. You can actually model the cracking of the concrete. It's very sophisticated software, unbelievably powerful, very, very powerful software. And it's used in aerospace. It's used by car manufacturers, car designers, used in all kinds of different fields, but very advanced in civil and structural engineering.
Okay, so thank you all for participating in this unique session. It's around 11 o'clock midnight time in India, but
Yes.
still people are participating. So so that itself shows that there is a interest, there is a curiosity. And, definitely, we must have this kind of a sessions in a future. We'll be recording this entire session. So whatever points you raised in the chat box, that also we'll be going through again. As well as we have also received many points through YouTube. That also we will be taking up, and we'll be coming shortly with the part two whenever the time permits. Okay, and we are very much thankful of Dr. Dilip Khatri for sparing his valuable time with us and sharing his insights on this retrofitting, which is very important subject.
Thank you.
Yeah,
Thank you for inviting me.
yeah. Most welcome. Yeah,
Very
yeah,
kind of you. We
yeah.
do another session soon, and maybe on some other interesting topic. And I thank you very kindly for inviting me.
Yeah.
Thank you to your audience. And when you do get the recorded version put together, let me know. I'll post it on my LinkedIn page and my YouTube.
Yes.
And I really thank you for inviting me. It's been a pleasure.
Yes. Yes. Okay. 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 So we are closing the session now, and this session will be uploaded on YouTube also immediately after end of this stream. So you can post your further comments on that stream also. So that will be picking certain points in the next upcoming session. Okay. So good night, everyone,
Thank
and
you very much.
thank you very
Thank you.
much. Thank you
Okay.
very much.
Have a good night.
Bye.
Thank you.
Bye. Good
Bye bye.
night. Good night.